Today we'll be starting Chapter 3. Chapter 3 deals with congruent figures. Most of the chapter deals with proving triangles congruent and steps that go along with that. So this chapter does have a lot of proofs in it, but today we're not going to start with proofs. We're going to just talk about what it means for figures to be congruent. So congruent figures, in general, are congruent if one of them is placed on top of the other and it fits exactly, point for point, side for side, angle. Okay, so again, one figure is placed on top of the other figure and it fits exactly, point for point, segment for segment, angle for angle. So we say in general they have the same size and shape. Okay, looking at the below picture, it shows two triangles. One fits on top of the other and they fit exactly point for point, angle for angle, and side for side. They are congruent parts. So every triangle has 6 parts. There's 3 angles. In this picture we have angle A congruent to angle D. Angle D will be congruent to angle E. And angle C is congruent to angle F. And same with the sides. So I'm going to go to green. AB is congruent to DE. We have EF congruent to BC. And the last one, DF congruent to AC. AC first, congruent to DE. Okay, so because these triangles are congruent, we can write this triangle congruency statement. Triangle ABC is congruent to triangle DEF. Okay, congruent triangles basically means all corresponding angles and sides are congruent. Okay, so corresponding angles and sides, angle A corresponds with angle D, B with E, C with F, and same with the sides. So looking at this question right here, can triangle ABC be congruent to triangle FED? Well, does angle A equal angle F? Angle A is here, F is over here. So actually these are not congruent, so this cannot work. Reason why? Because order does matter in the congruency statement. Order matters, and angle A is not congruent to angle F. Alright, moving on to congruent polygons. What is a polygon? Polygon is what you say when your pet carrot flies away. Polygon, polygon, polygon. Get it? Congruent polygons actually are the same thing as congruent triangles. Polygon is just a type. A triangle is a polygon. We have rectangles, squares. Just circles just can't be polygons. So same thing here. Where we have all pairs of corresponding angles and sides are congruent to each other. Okay, let's talk a little bit about reflection. So this is a reflection of a triangle. We have triangle KIT. And if I reflect it over, I get triangle KET. Okay, notice that angle I will be reflected over, and we get angle E, angle 1, and angle 2 is a reflection, and same with angle 3 and angle 4. Okay, so it's reflected over. We've talked about this before, the reflexive property, which is any segment or angle. It's got to be congruent to itself. Okay, so I could say an angle is congruent to itself, or a segment is congruent. Looking at this picture here, what would come in handy in a proof is that KT is congruent to itself, because it's part of both triangles, triangle KIT and triangle KET. So that would help us prove triangles congruent. So an example would be KT is congruent to KT. Another example is down below right here. Okay, I don't know if you can see it, but we do have 2 triangles. The one on the left and the one on the right. Okay, and we do have something that's being overlapped. In this case, it's not a side. it's an angle. Angle Q is in both. So this one I could say angle Q is congruent to angle Q, and that will greatly help me in proofs. A couple more things before we end today is slide. When you slide something, you move it horizontally. And when you rotate something, you rotate it or you move it around a fixed point. So you're just turning it a certain amount of degrees, either to the right or to the left, clockwise or counterclockwise. Alright, so let's move on to some examples. Here we have a triangle congruency statement. Triangle NBC is congruent to triangle FOX. So we are going to name this as congruent parts. Remember, we have 3 congruent angles and 3 congruent sides. So first off, for the angles, we have angle N congruent to angle F, angle M congruent, angle B, congruent to angle O, and angle C congruent to angle X. Okay, notice the first letter matches with the first letter, middle with middle, and last letter with last letter. Okay, when we do segments, same thing, except we have 2 letters, NB congruent to FO. We have BC congruent to OX. And last but not least, CN congruent to XF. Again, these can be reversed if you want, and it's the exact same thing. Okay, looking at number 2. We have triangle PRT is congruent to triangle YVN. Okay, we want to find the measure of angle N and segment YN. So, remember, if N is the last letter in this congruency statement, it's going to match with the last letter in this one, so these will be congruent. Okay, so we know T is 36, so I can just say that N is also 36. Okay, they are congruent, so they are equal. Same with the segments, we have YN. Okay, this one you can kind of look at the picture. The hypotenuse here is PT. Remember, hypotenuse is across from 90 degrees. So the hypotenuse here, YN, would be the same 10 as the other triangle. So this would be 10. Again, if you wanted, you could look at the order of the letters. YN is the last 2 letters. So the first and last letter here is B and T. And that's the segment 10. Okay, number 3 has the triangles already marked. So what we want to do here is write our own triangle congruency statement. We have A, B, C, so we have to be careful in the order that we write these letters to make sure it's correct. A matches with Y, so Y has to be first. B is going to match with Q, so Q is the middle letter. And C, these are vertical angles, so we know that vertical angles are congruent. Okay, last problem. We're going to throw in some algebra here. We have the 2 triangles congruent, triangle ABC congruent to triangle EDF. However, there is a change from yours. This should say minus 10, or else the problem will not work. So make sure your ED is 4x minus 10. Because these are corresponding parts, A, B, and ED, we're going to set them equal to each other. So 2x equals 4x minus 10. And I'm going ahead and find x, subtract 4x to both sides. Negative 2x equals negative 10. And divide by negative 2, I get x equals 5. And that concludes our notes for today.